Hi. So, in the previous video, we learned what are the ingredients of an economic mathematical model. Now, we're going to consider the first simple model that you already discussed in your microeconomics class, but now we're going to look at it from a slightly different perspective. Okay, so what do we have here? Here we got that quantity demanded is equal to A minus B times P, where P is of course price. QS equals to minus, up front, so negative C minus C plus D times P. And here we've got equation that states that quantity demanded is equal to quantity supplied. Finally, we see from here that A, B, C, and D are all positive. Okay, so what does it all amount to? Look, what we are going to do over here is partial market equilibrium model. What does it mean that this is partial equilibrium model? Look, imagine that there's an entire economy, but out of this entire economy, we're just counting out one market. We're assuming that everything else stays the same. It's like frozen, and we are just interested in what is happening in this model. Okay, so we've learned about different types of equations and variables. So now let's figure out how would we classify the ones that we've got in these three equations. Okay, so here we've got demand. Look, this is a function that is showing us what is the quantity demanded by customers as a function of changing the price. Now, what type of equation is that? Well, this is a behavioral equation because it shows us how customers behave in response to changes in the price level. Now, over here, we've got the same type of equation, also behavioral equation, but this is a supply equation, right? We see how quantity supplied by the companies depends on the price of the good that is being considered. And finally, the last one, quantity demanded and quantity equals to quantity supplied. Well, that is an equilibrium condition. Here we see that if quantity demanded is exactly equal to quantity supplied, we will have equilibrium price and equilibrium quantity. So this is how we actually can solve this model. Okay, let me just notice a couple of things here. Look, first, quantity demanded is equals to quantity supplied condition is equivalent to another condition, that QD minus QS equals to 0. What is this QD minus QS? This is the difference between demand and supply. So in other words, this is excess demand. Yeah. So we see that when excess demand is exactly 0, so there's no higher demand than supply, we will have equilibrium in the model. Okay, so let's use what we've got here to draw the model before we're going to start solving. Okay, let's notice a couple of things. Oh, maybe, you know what? There's going to be something very, very new at this moment. Look, when I'm gonna start drawing this, you'll see something very weird. I'm gonna put price over here and quantity demanded and quantity supplied over here. Well, this is not how you used to see it in economics, in microeconomics, right? You usually see it the other way around. Quantity is here, price is here, this is demand, this is supply. But look, this view actually is not the best one. It's the one that as a convention was adopted through economics, and now you see it in every microeconomics textbook. But then, that was actually an issue because we're gonna draw demand and supply in a space where price is on the horizontal axis, right? We usually think of horizontal axis as an argument. So this variable on horizontal axis has some influence on the variable that is on the vertical axis, right? And look, this is better description of the reality than this one. Why is it so? Look, quantities, when you make a decision about how much to buy, you do not observe quantities as a customer. You do not know how many units of each of the goods is in every shop. But you can easily check the prices at each shop, choose the smallest one, the lowest one. And the same goes for producers. Producers don't know how much in their stock their competition has, but they can easily check what is the price in their competition. So actually the variable that gives us the knowledge about what is happening on the market is price. So the price actually gives us quantities that we are discussing. The difference was here conventional because there were these two economists, and one was Marshall, and one was Valrat. The first one was British, second one was French. Valrat wanted this graph to be established in this way, the way we're going to do it, but Marshall gained a lot of popularity with his graph. He actually said that it's inconsequential, because to some extent it is, but actually the view where prices are guiding quantity is better, and we're going to stick to this one because this is appropriate one. Okay, so now let's start drawing what we have over here. Look, so on this axis we've got quantity, we've got price, this is 0. Let's start by drawing demand. What do we see over here? Look, we see that within these three equations, we've got some variables that are influencing one another. For example, quantity price influences quantity demand. But of course, we could say that quantity demand influences the price the same way. Quantity supply influences the price, and vice versa. And quantity supply influences quantity demand through equilibrium condition. So those those three variables actually are somehow related to one another. Those are our endogenous variables. Those are the variables within these models we actually can try to explain. But what about A, B, C, and D? Those are given. We are not trying to explain why they are like this in this model. We are just simply assuming that they are there. And we can now clearly see that A and C are constants, while B and D are just parameters. Okay, so now that we've got all the ingredients, we are absolutely ready to see what's going on over here. Let's start with quantity demanded. Look, quantity demanded, when price is 0, is equal to A. Now, quantity demanded is also a function of P. And look, the higher is the P, the lower is quantity demanded, because parameter here has a minus up front, right? We can think about it in different ways, but look, if you think about it as a function, y equals a minus bx, if you want to know what happens to y when x is changing, you calculate the derivative. And look, we can do the same thing here, no problem. If I differentiate quantity demanded with respect to price, I'm going to get that this is negative b. So each time when price increases by some small amount, very, very tiny amount, quantity demand declines by minus b. So this is actually a linear function, right, that goes down. Now, the question is, how much do we have here? Well, it's really easy to calculate, because at this point we see that quantity demanded is 0. So we've got 0 equals A minus BP. So we get that BP is equal to A and P is equal to A over B. Okay, now what is A over B? Look, what is so specific about this A over B over here? A over B is some price. This is a prohibitive price. If price is so high as A over B, customers stop purchasing the good. Okay, so we know now quite a lot about our demand function. This is quantity demanded, or we can just write demand like D, the same thing. Okay, but we know what is B. B is telling us like how much customers reduce their spending on this particular good when price is rising. It's somehow connected to elasticity, but this topic we're going to take up in more detail a little bit later. We know what is the prohibitive price. We know that if price would be 0, customers would buy A units. So at most. So now the question is, what is this A in our example? Exactly. Well, look, A in this setting is something that we usually call catch-all variable. So everything that is not explained within this model but is relevant to it could be subsumed into A. What do I mean by that? Look, A, for example, could be customers' income. Right? Look, assuming that good is normal, we expect that the higher is the customer's income, the higher is demand for some good. And look, if customer's income goes up, we would see that A is actually getting bigger and demand in increases, right? Those are those demand shifters that you were discussing during your those determinants of demand you were discussing during your microeconomics class. Okay, so now we know quite a lot about demand. We draw it. It wasn't that bad. Now let's move to supply. Okay, so what do we know about supply? Actually, when price is zero, quantity supply is negative. Well, of course, look, in reality, we do not have negative quantities. It's really hard to imagine, although probably you could give an example with the things you've got being destroyed or something like that. But we do not interpret it that much. It's not going to be that important. But look, then we start from this point. And we see that D is positive. D, just like we have here, is simply derivative of quantity supplied with respect to price. Because D is positive by assumption, we know that the higher the price, the more the companies are willing to supply. And this is how we get QS, so quantity supply, or simply the supply curve. Okay, so you see that this gives us the slope, right? So again, it's going to be somehow associated with the elasticity of supply, which we will cover later. But this is not what is important to us at this moment. What we want to know now is what is this point, right? And look, if we would, in order to find it, we want to know what is the price when quantity supply is equal to 0. So look, in this exercise, we can use the same reasoning as before. So we've got a Q is equal to 0. We've got minus C plus dP, and we can solve it in exactly the same way, and we will get that price is equal to C over D. Okay, and now the question, or interesting question, is what is the C over D? And whether it makes sense that we have negative values. Actually, it makes perfect sense. Why? Look, imagine that cost of producing your good is $1. If the price of this good on the market is 50 cents, would you produce this good? Well, definitely not if you're a rational human being, right? Because you would be just losing money. So how much, at least, in order for you to produce, the price needs to be at least a little bit bigger than the cost of production. Like we can say that this cost of production includes taxes or other unit cost of production, and this is our unit cost of production. Because at this point, we see that from this moment on, it's actually becoming profitable to produce. So this is the point C over D. So now look, by the same token, we can, as we got those two, we can also compare those two expressions. This is also a catch-all variable that will be a supply curve shifter. You can think about it as costs of factors of production materials or taxes. So everything that moved supply curve in our previous in your previous class in microeconomics is also can be thought of as a part of this C. Okay, so now we've got a graph, but we still don't have everything over here. Okay, because look, when you were doing a market model in microeconomics class, of course what you had, what was interesting to you, what was the equilibrium price. The price that you get when quantity demanded is equal to quantity supplied. And this is the next step in our analysis. What we want to do now is to find what is the quantity demanded and what is the quantity supplied, but in equilibrium. So equilibrium price and equilibrium quantity. Okay, so how do we go? Okay, first, let's use the information that we've got in the model. Look, we know that equilibrium condition is quantity demanded equals to quantity supplied. But if they are equal, I can replace them with just one Q, right? And this actually has some extreme consequences on solving the model. Because look, now, if they are both equal to Q, I can replace QD and QS with Q over here. But then, in order to solve this system of simultaneous equations, we would like to take one additional step. And this is a step that we will be taking from this moment on very, very often. So please remember about it. When we got our system that we are trying to solve to find equilibrium price and equilibrium quantity, first thing we do, put all the endogenous variables on the left and leave everything exogenous, so constant terms, because of course we need to move them with parameters. We leave them on the right. So look, here we've got so here we just move expressions with prices to the right. Okay, and look, now that we've got it in this form, what we should do next? Put it into matrix notation exactly as we did in mathematics class. So, we've got here first quantity, then price. Here we will have constant A here, constant minus C, negative C, and look, here coefficient on Q is 1, coefficient on P is first B, then negative D. Okay, so now our entire job is to solve this system of simultaneous equations. We're going to do it with Cramer's rule because it's extremely easy in this context. Okay, and what do we have over here? Well, we start by calculating the determinant to determine whether we actually have an equilibrium solution or not. Okay, so our determinant is very simple, 1, 1, B minus D. So we've got that this is D, minus D, this is minus D, minus B, or put it simply, if I'm going to take minus and rearrange, this is negative B plus D. Okay, and now look, what was is the condition for the existence of the solution in mathematics class and for the existence of equilibrium in this case? Well, determinant should be different than 0. But is it? Well, we know by assumption that B is positive and D is positive. So they are both positive. We've got positive, when we add two positive expressions, it remains positive. We minus the front. This is clearly negative. And because this is negative, we know it's different than 0. So we know that the solutions exist. Okay, and look, now to find those solutions, we can continue using Cramer's rule. And look, I'm going to use it in a different order than we used to, because we usually started by replacing the first column. I'm going to start with the second one because it's easier, and then we're going to move to quantity, which is more complex. So I calculate now A, P, because now we are solving for price. So I'm taking this column, this vector, and I'm replacing first column of this matrix. So I'm getting that this is 1, 1, A minus C. After calculation, we are getting that this is negative C minus A, or negative A plus C. Okay, and from that, we can get equilibrium price. Equilibrium price is equal to AP over A, and it's equal to negative A plus C over negative B plus D. But of course, those two cancel each other out, so we end up with just A plus C over B plus D. What is important over here is to notice that all those components, B plus D, A and C, they're all positive, so we can be sure that the equilibrium price that we've calculated over here is bigger than 0, which has sense not only mathematically, but also economically. Okay, so look, now, knowing this, I can put equilibrium price on the graph. Okay, now that we have equilibrium price, let's go for equilibrium quantity. So now we are replacing the first column, right? So we calculate AQ. We put there A minus C, we've got B minus D. Okay, we get out of this that this is negative AB plus, because remember when we go upstairs we get minus, plus BC. However, again, let's take minus out, and we are getting that this is negative AB minus BC. Okay. So, what do we do next? Well, we of course calculate equilibrium quantity the same way as we calculated equilibrium price. So, equilibrium quantity is given as AQ over A, and it's equal to negative AB minus BC over negative, it was negative B plus T. Right? Because we can use the determinant. Right? Again, we can get rid of the minuses, and we get that this is, then we got this is AB minus BC over B plus D. And this is our equilibrium quantity. However, there is a small problem with this equilibrium quantity. Because look, we see here that B and D are positive, right? So B plus D will definitely be positive. However, A and D are also positive, so this expression is also positive, and this expression, B times C, is also positive. A, B, C, and D are positive. So look, here, we do not have the guarantee that this expression is going to be positive. We see that A times D can be smaller than B times C, and in this case, this could mean that our quantity is negative. To avoid this issue over here, to avoid the issue of this expression being negative, we need to add one additional simple assumption. And this assumption is that this is bigger than 0 if and only if AD is bigger than BC. Okay, and now we've got equilibrium quantity that we can also place on our graph. Okay, so now you've seen how we solve, how we find the equilibrium in a simple partial market model. So, what we are going to, we're going to stop at this point, because at the beginning we're going to just learn how to solve models. But remember that we're actually going to be coming back to this market model many times. We're going to be doing new things with this model. We're going to be adding some new techniques that you don't know to it. So we can analyze more. We can analyze it more properly. But I just wanted to mention one thing, which is actually skipping ahead a little bit. Look, now that we know how price is depending on A, B, C, and D, and Q how depends on A, B, C, and D, we will be able, using some things that you already actually know, assuming you appropriated the knowledge in the mathematics class, on how those variables, how those parameters and constants will be affecting equilibrium price and equilibrium quantity. Okay, but this is it for now. During the next video, we're going to move ahead and we're going to have general, let's call it general equilibrium, general market equilibrium. But of course, we're just going to do a simple version of that. And what do I mean by a simple version of that? A version in which we have just two markets. But I hope once you understand how it works in two markets, you will see how easily it could be extended to n markets, but of course at the cost of greater complexity. Okay, thank you for your attention and see you in the next video.